Okay, here we go with 5.1, problem number 7. We'll do a bunch on this video because I think they go pretty fast. Verify the following is a probability model. What do you call the outcome blue? Well, to be a probability model means, all of these have to add up to 1. So 0.3 plus 0.15 plus 0.15 is 0.3, so that's 0.6 plus 0.4 is in fact 1.0. So that adds up to 1, so it's a probability model. And what do you call the outcome blue? Outcome blue, well, as it says right here, it's impossible. It's just not going to happen because the chance of it happening is 0. So it's an impossible event. All right, number 8. What's probability, or the following is a probability model? If the model represents color of M&Ms, what does the model imply? Well, what this is saying is the chance of a red is 0, green is 0, blue is 0, brown is 0, orange is 0, but the probability of yellow is 1 or 100%. So that means everything in the bag is yellow because you have a 100% chance of getting a yellow. So all of the M&Ms are yellow. Okay, does that make sense? If it doesn't, then just talk to your computer and I'm sure it'll answer you right. Actually, if it doesn't make sense, then talk to me in class about it. Number 9. Why is the following not a probability model? Well, 1, to be a probability model, all of these have to add up to 1, and the smallest probability is 0 and the largest is 1, and right off the bat we see that that's negative, so that is no good. The probability of green, well, there it is right there. Probability of green is less than 0, so that makes it bad. So not a probability model there. Okay, 18. Blood type. A person can have one of 4 blood types. A, B, or O. If you pick a person at random, what's probably that blood type A? What's probably that blood type A? Most people would probably say, well, 1 in 4. Well, that's if these are all equally likely, or in other words, if they all have the same chance of happening. Well, more people have type O than any other type, so there's a higher chance that they have type O. That's why we make a probability model, and you can actually look up the probabilities of these different ones, but it is certainly not 1/4, 1/4, 1/4, 1/4. So that is not the case that they're all equally likely or the same. Equally likely means that they're all the same probability, which in these cases, these are all different probabilities. Okay, different blood types. AB is really rare, in fact. 19. If a person rolls a 6-sided dice and then flips a coin, describe the sample space of possible outcomes using 1, 2, 3, 4, 5, 6 and the outcomes heads and tails. So the sample space for number 19, S, would be, well, I'm just going to list them here. You could get a 1 in a heads, a 2 in a heads, 3 in a heads, 4 in a heads, 5 in a heads, 6 in a heads, or you could get a 1 in a tails, 2 in a tails, 3 in a tails, 4 in a tails, 5 in a tails, or a 6 in a tails. Those are all the outcomes that you could get flipping a coin or rolling a dice and flipping a coin. And 21. According to the Department of Education, 42.8% of 3-year-olds are enrolled in daycare. What's the probability that a randomly selected 3-year-old is enrolled in daycare? 42.8%. Or sometimes we write it as a decimal, 0.428. Okay, there we go. We'll leave it at that.